Hello dear students, welcome in this channel Patel Science Academy. In this channel you are going to learn about the embryo development. So development of the embryo is the topic of this lecture, and the what is this embryo I'll explain in a very easiest way to you. The process of development of zygote into an embryo, this is called embryogenesis. So simply, embryogenesis means the process of formation of embryo from the zygote. So actually, this is a zygote, and this is that zygote, and which is 2n in number, and it is always formed, as you know, by the fusion of the single N male gamete with the fusion of single N egg. Likewise, 2n structure. This zygote is formed here in the gynecium, and if it is going to produced into this structure having some changes, this likewise and likewise, so this zygote in the further developmental stage is called embryo. So I'll explain all these embryo structure in detail. You just stay here till the end of this video. And the embryo is developed at the micropylar end of the embryo sac. So this is important thing. This embryo develops towards the micropylar end. As you know, this is embryo sac, and in this embryo sac, this is chalazal region and this is micropylar region. So you can see here, this embryo is developing towards the micropylar end. The growth of the embryo triggers after the certain amount of endosperm is formed. So dear learner, after fertilization, the embryonic development begins, and the zygote undergoes for the two-cell pro-embryo this change. So this is a zygote, and it undergoes for the cell division to form this two-cell structure. One you can observe here at the micropylar end, and one as the chalazal end. This is chalazal end, and this is micropylar end. Towards the micropylar end, you can observe this green colored cell, and towards the micropylar chalazal end, you can observe this blue color cell. So zygote very at first is going to divide into two cell structure, that is green color and blue color structure. What are the names of this green color and blue color cell? You are one thing observing here, this green color cell is larger. It is towards the micropylar end, and it is called a basal cell or the suspensor initial cell. So this green color cell which is formed towards the micropylar end, it is called basal cell or suspensor initial cell. Remember this term. And this is a smaller term, a smaller cell, you can see here, which is blue in color, and this smaller cell is towards the region of the chalaza. As you know, this is chalaza region, and this is called terminal cells or embryonal cells. So likewise, till now, two types of cell from the zygote has been produced. One towards the one larger cell known as the suspensor initial or basal cell, and one smaller cell which is called a terminal cell or the embryonal cell towards the chalaza region. So likewise, till now, zygote is converted into pro-embryo, and this pro-embryo is having these two structure. As I have explained it, this is larger basal cells towards the micropylar end, green in color, and this is a smaller terminal cells towards the chalazal end, which is also called as embryonal initial cell, and it is blue in color. So till now, dear students, I hope I hope you have understood about the division of the zygote. It goes for the first cell division, converts into this suspensor initial cell, larger cell, and the terminal cell. Now we'll go for the next slide, and in this slide we'll see both the cell of the suspensor initial, both the cell, that is the suspensor initial, and the embryonal initial, it goes for the cell division together. So it means they start cell division together. Means the green color structure or a green color cell and the blue color cell both start dividing together. So I'm explaining here first the cell division of this suspensor cell, which is green in color. So this suspensor cell divides transversely. This is most important point for this cell division. it start dividing transversely. As you can observe here, it start dividing transversely, and this transverse division results in the formation of the in a one plane to produce the filamentous suspensor of the 6 to 10 cell, as you can see here. So this suspensor cell transversely divides and form this structure. Out of this structure you are observing I think one important thing. First, or the top cell is bigger in size, and rest of the cells in the plane is smaller in size. So this structure, which is having this 6 to 10 cells, likewise it is called filamentous suspensor. So I hope you have understood about the suspensor cell development, further development, and now I'm going to explain about this cell and this cell, what are the terms. Together this larger and smaller cell is called filamentous suspensor. Then what happens with this filamentous suspensor, and what are the terms we use for this filamentous suspensor? The first cells of the suspensor towards the microvillar end, as you can observe here, this one, the bigger one, it becomes swollen and function as a haustorium. So you can see here, this is haustorium, and the lowermost cell in the suspensor is known as hypophysis. So this is hypophysis, as you can see here. So suspensor cell till now has converted into the haustorium, that is the bigger one, and the hypophysis, that is the linear smaller one. So suspensor helps in pushing the embryo in the endosperm. This is the function of this suspensor. It helps in pushing the embryo in the endosperm, likewise. So till now haustorium and the hypophysis in the suspensor cell in the filamentous suspensor has been developed. Now the next slides, the embryonal cells. What happens with this blue color structure, which is called embryonal cell, terminal cell? This embryonal cell, it undergoes for the initial it undergoes for the 3 successive mitotic cell division, that is mitosis cell division, to form the octant, means the structure which is having 8 cell. The plane of the division are at right angles. This is also again important thing, it can be asked in the final examination in the MCQ section. It goes at for the cell division at a right angle to each other, and likewise there is a formation of this octant in this structure. So look at this blue color structure, embryonal, initial or terminal cell. It goes for the first meiotic cell division and it converts into 2 cell structure, you can see here, and this 2 cell structure, it goes for the second meiotic division and it converts into 4 cell structure, and this 4 cell structure, it goes for the third meiotic division, and this third as a result of the third meiotic cell division, 8 cell structure is formed here. You can see here, because there are 8 cell in this structure, it is called octant stage. So likewise this terminal cells now is converted into this octant stage, and this suspensor cell is now converted into filamentous suspensor, in which haustorium is there and hypophysis is there. So dear students, I hope till now you have understood what happens with that zygote. It has converted now into the filamentous structure and the octant stage. Now we'll go for the next stage. The lower tiers of this 4 cell octant give rise to the hypocotyl and the radicals. So this out of that 8 cell in the octant stage, 4 lower tiers, it goes for the formation of the hypocotyl and the radicals, whereas the 4 cells of the upper tier forms the plumule and one of the 2 cotyledons. So you can see here the changes in this structure. You can see here the changes in this structure in this octant. This is a lower octant, and this is upper higher octant, or higher tier or lower tier. So this 4 cell towards the lower tier, it is going to convert into the hypocotyl and the radical, and the 4 cell in the higher tier is going to convert into the plumule and the one or two cotyledons. If dicotyledon is there, two cotyledon will be formed, and one monocotyledon is there, one cotyledon will be formed. So likewise, this is the conversion of the octant lower and higher tier 4 cells into the hypocotyl, radical, plumule and cotyledons. So the hypophysis by further division gave rise to the part of the radicle and the root cap. As you know, this is hypophysis and this is haustorium. So this hypophysis, it undergoes for the cell division. It forms the parts of the radicals and the root cap. Now in the next stage, likewise we'll summarize the structure. So till now we have seen zygote has been converted into this green color structure, that is suspensor cell, and into this blue color structure, that is a terminal or terminal initial cell. So this suspensor cell, it has converted into this structure, this is called haustorium, this is called hypophysis, and this terminal cell has been converted into this structure, which has now converted into the radicals, hypocotyl, plumules and cotyledons. Now just this octant, now this octant is just going to change its shape, and what are the changes I'll explain in the next slide. Subsequently, the cell in the upper tier of the octant, it divides several planes so as to become the heart shape. So you can see here this octant now is going to divide, and it assumes this heart shape, and now it is called heart shape embryo. So you can see here the shape of this embryo, it is now becoming or looking like a heart, which then forms two lateral cotyledons and terminals plumules. So you can see here this heart shape octant now is converting into this two cotyledons. You can observe here this is one and this is second cotyledons, this is a radical, as you know, this is plumule. So this is the changes taking place in this octant stage. Likewise, now cotyledons, two cotyledons has been produced and plumules is also produced. So heart shape of this octant now is converted into this structure. Now it goes for the further development and further enlargement of the hypocotyl. Further enlargement of this hypocotyl and cotyledons result in the curvature of the embryo. Because of that hypocotyl and cotyledon formation or enlargement, this embryo shows a curvature, and it appears like a horseshoe shape. So you can observe here in this structure the shape of this octant, which was previously like a shoe, like a heart shape. Because of the development, because of the enlargement of the cotyledons and the hypocotyl, it has now assumed this horseshoe shaped. So this structure with this horseshoe shaped embryo is called horseshoe shaped embryo. Now for the next stages, this embryo development is similar in the both cotyledon and dicotyledon and monocotyledon. Up to the octant stage, the development of this embryo is similar, as you can see here. This zygote, it converts into two cell structure, which is called the suspensor cell, and the embryonal cell, suspensor cell, convert into this structure, filamentous suspensor, in which this structure and this structure haustorium and the hypophysis is formed, and this embryonal cell convert into two cell, four cell, and finally into octant stage. And octant stage, then upper tier and lower tier finally converts into cotyledon, plumule, radicals, etc. in this structure. And likewise, the development of the embryo in the different mono and the dicotyledon takes place. In the monocotyledons, finally in the monocotyledons, the monocot embryo because it is having single cotyledon, it occupies the terminal position and plumule is lateral. So you can see here in this diagram, the monocotyledon is occupying the terminal position, and the plumule is laterally assuming this position. The single shaped cotyledon is called scutellum, and the protective sheet of the plumule is called coleoptile, and that of the radicle is called coleorhiza. So likewise, in this structure of the monocotyledon plant, you can see these changes here. And this is about this lecture, development of embryo. Dear students, don't forget to subscribe my channel Patel Science Academy, and if you are having any confusion in your mind regarding this lecture or previous lecture, you can ask me. I'll try to answer your all questions in a very easiest way. So please subscribe my channel Patel Science Academy, and share it, comment it, and be healthy. This is Sheza sir saying you goodbye.